So in this video we're going to be solving these equations where we have x in the denominator. So in each of these cases what we need to do, remember, is to isolate the x. But sometimes, rather than dealing with the number first, so if you see like a 5 in the first example and you think, well, I should deal with that first, when you have x in the denominator, then what you should do is you should work with that first, okay? So think about making sure that the x gets into the numerator or it's not within the denominator of a fraction, okay? So I'm going to show you two ways of tackling this problem, okay? So the first way is to consider, just like before, if we had x over 2 is equal to 3, what you would do is you would say, well, I've got x divided by 2 here, and so I would multiply both sides by 2, and I would get x is equal to 6. So here you've got 5 divided by x, so what we'll do is we'll multiply both sides by x. So if you multiply both sides by x, you get 5 on the left-hand side, and then 1 times x on the right-hand side. Okay? And so you get 5 equals x, or if you rewrite it with x equals, that would be x equals 5. Okay? So, I think what I'll do is I'll go through each of these 6 using this method first, and then I will do the secondary method immediately afterwards. Okay? So if you want to see both methods, then stick around. So, number 2, we've got the x on the right-hand side of the equation now, but no worries. We've got 8 divided by x, so what we'll do is we'll multiply both sides by x. On the left-hand side, we'll have 1 times x, which is x, and on the right-hand side, we'll just have 8. And so x equals 8 is the solution. Number 3, we're back to x being on the left-hand side. So we've got 6 divided by x, so we'll multiply both sides by x. So we'll get 6 is equal to 2 times x, so 2x. Now we're going to have to do one more step now, okay? So because we've got 2 times x, we haven't got x by itself. So I'm going to need to divide both sides now by 2. So 6 divided by 2 is 3. 2x divided by 2 is just, of course, x. And so then you can write that as x equals 3. Right, number 4. We have 4 equals 12 over x, so we're dividing by x here. So we're going to multiply both sides by x to start off with. 4x is equal to 12. And then, because I've got 4x, so I'm multiplying by 4, I need to do the opposite to that and divide both sides by 4. So I'll get x on the left-hand side. 12 divided by 4 is 3. Right, number 5. 5 divided by x is 8. So if I multiply both sides by x first, on the left-hand side I have 5. On the right-hand side I'm going to have 8x. So we're multiplying x by 8. So I need to divide both sides by 8. So 5 divided by 8 is 5/8. And so x is equal to 5/8. Now, last one, number 6. 20 equals 15 over x. So I'm dividing by x, so I'm going to multiply both sides by x first. So I'm going to get 20x on the left-hand side and just 15 on the right-hand side. Okay? 20x equals 15, so I'm multiplying by 20. So I'm going to divide both sides by 20. Divide the left-hand side by 20, I'm just left with x. On the right-hand side, I'm going to have 15 divided by 20, or 15/20. Now this is a fraction that can be simplified because you can divide top and bottom by 5, and that will get us 3 over 4, so 3/4. So that is one way of solving all of these equations. Okay? So now I'm going to show you an alternative. Okay. So, the idea behind this is, as you know, we've been applying the same process to both sides of the equation. So whatever you do to one side, you have to do to the other. Okay? Regardless of whether that's multiplying, dividing, adding, or subtracting. Now, one thing that you can do also, which it's not that you're doing anything that's beyond multiplying and dividing, it's the case of that what you can do actually utilizes those processes, okay? But you're doing it in one step. So I'll show you what I mean. Let's say, for argument's sake, that we have, well, shall we go with 5 over x equals 1? We'll just do it with that one. No, actually, let's change this to 10. So 5 over x equals 10. Well, when you multiply both sides by x, you get 5 equals 10x. And then you divide both sides by 10, so you get 5 over 10 is equal to x. Okay? Now, I'm going to go one step further here. Okay, and I am going to divide both sides by 5. Now, this isn't something that you would do in order to solve the equation, but I'm just manipulating the algebra to get it into a format that I want it to be in. Okay, so I'm going to divide both sides by 5. Now, if you divide 5/10 by 5, you just get left with 1/10. You had 5 of them, you've now got 1 of them. And if you divide the right-hand side by 5, you get this. Okay? And of course, you can write those the other way around as well. Okay, we're all in agreement of that. Okay, now, if you're happy with all of those steps that I've made, excellent. I now want you to compare just the first line and the last one. I'm going to write it underneath. Now, these two lines have to be equivalent. I've shown algebraically that they are equivalent. Okay? So, 5 over x has become x over 5. 10 has become 1 over 10. So what's happened is that you have found the reciprocal of both sides of those equations, of both sides of the equation. So the reciprocal of a fraction flips it upside down. The numerator becomes the denominator becomes the numerator. Okay, and the 10, which is 10 over 1, becomes 1/10. And so what that process does is it changes x from being in the denominator to being in the numerator, which makes your life a lot easier. So if we use that method as a stepping stone for each of these, the first equation, if we find the reciprocal both sides, becomes x over 5, and 1 is just 1 over 1, so its reciprocal is just 1. The problem reduces to this, and then you can multiply both sides by 5, because we're dividing by 5 there, so we'll multiply both sides by 5, and we get x equals 5. What about with this one? The reciprocal of 1 is 1. The reciprocal of 8 over x is x over 8. So we're dividing by 8, so we just multiply both sides by 8. And we get x equals 8. Likewise this one. Reciprocal both sides, so we're going to get x over 6. The reciprocal of 2 is 1/2. So now you're going to multiply both sides by 6. You're dividing by 6 here, so we'll multiply both sides by 6. We're going to get x equals 6 times 1/2, which is 6 over 2. So the 6 multiplies with the numerator. 6 divided by 2 is, of course, 3. 4 equals 12 over x. Find the reciprocal of both sides. Dividing by 12, so multiply both sides by 12. So we're going to get 12 over 4 is equal to x. So x is equal to 12 over 4, which we know is 3. This one, reciprocal both sides, x over 5 is equal to 1 over 8. And then multiply both sides by 5. So x is 5 over 8. And the last one, find the reciprocal both sides, so 1 over 20 is equal to x over 15. Multiply both sides by 15. So 15 over 20, divide both sides, top and bottom rather, by 5, and we're going to get 3 over 4. Okay, so either of those two methods will work. I don't think there's necessarily a speeding up in either of those two methods. I don't think one necessarily goes faster than the other, but this is a very useful technique to have, and it might make your life easier.